Okay, so is everything visible right now? नहीं है तो बताओ, अभी तो कुछ visible नहीं है। Okay, so what we were doing some modified expression to the Gauss law, and we were trying to obtain a few like what I wanted to say. I knew there was some technical glitch because of which I wanted to teach you something. Like what I can do is instead of a group. So uh, here what I can do is what I would do is probably see at times if I would have integrated it from both sides. For example, there is a what I can say. What I would do, for example, I wanted you to understand this particular thing, but okay, there was a technical problem, so it slightly got delayed. The point is, what I want to suggest is, see, जब भी तुम्हें यहाँ पे एक r square दिखे ना और यहाँ एक r दिख रहा है, तो थोड़ा एक काम करो, just try to expand it instead of going all out. थोड़ा सा एक माइनस भी होना चाहिए, एक माइनस होगा। अच्छा, मैंने r से इंफिनिटी कर दिया, ठीक है। So overall understand, इस पे काम करो, एक अलग एक्सप्रेशन लो, r से infinity, this is q upon r square e की power minus r upon lambda dr, and take this as another expression. Take this as another expression, that is r to infinity, and you have q upon r, sorry, q r upon lambda and e की power minus r. इसका फायदा क्या मैं बता रहा हूँ, देखो मेरी बात समझो. If this particular r square is there, if this particular r square is already there, what I can do is, if I want to integrate this up, if I want to integrate this thing up, keeping 1 upon r square as an integrable term. So इसलिए मैं कभी भी नहीं कहता कि याद करो Eilert principle और ये सब चीजें. I don't believe in all that shit. I am just saying, just try to understand if I take 1 upon r square as my integrable term, if I take my 1 upon r square as an integrable term, what will happen? Let's see. If I take 1 upon this particular 1 upon r square as my integrable term, so my potential as a function of r is given by 1 upon 4 pi epsilon naught, and this integration from r to infinity, what you can do, try to take this as integrable term. So if I take this as an integrable term, what will happen? Minus q upon r e की power minus r upon lambda, and then minus integral, the derivative of e की power minus r upon lambda would be e की power minus r upon lambda and into minus 1 upon lambda. And then again, integration of 1 upon r square will give me minus 1 upon r dr, and then this integral I'm writing as I2. Is that clear? This integral I'm writing as I2. I hope it is clear. So what will happen? My potential as a function of r will come out as 1 upon 4 pi epsilon naught, and then I have this minus q upon r written. So I'll place this q outside, and here you have minus r upon lambda upon r, from r to infinity की जगह again infinity to r goes to, okay, and then you have this minus, and just try to figure out ये क्या होगा. देखो r to infinity दिख रहा है, अब थोड़ा ध्यान से देखते, जो सेकंड टर्म उसको देखो, minus minus positive, again a minus, so overall again a minus, so you have this integral r to infinity, and this will be e की power minus r upon lambda divided by r lambda, and then you have d. Understand, this is nothing but your I2 only. This particular, both of these will get cancelled. Both of these will get cancelled. Is that clear? ये चीज आसान हो जाएगी तुम्हारे. So overall, you are left with this only this term. So what I will get? I will simply get my v as a function of r, which is nothing but q upon 4 pi epsilon naught, and here you have e की power minus r upon lambda divided by r, because at infinity this will go 0. So this is your potential as a function of r. Is that clear to you? ये चीज समझ में आई, ऊपर से चली गई. Is that clear? Am I audible?
Yes.
हाँ, okay. चलो, अब देखो इसके आगे, if I want to write my Gauss law, so what your Gauss law suggested? Your Gauss law suggested that integral E dot ds should come out as q upon epsilon naught if you had only your inverse square law forces. If you had only, if I was writing Gauss law for inverse square law forces, then E dot ds should give me the summation q upon epsilon naught. Is that clear? But now what it is going to give me, let us for simplicity take the charge q, and if I make a sphere of radius capital R, if I make a sphere of radius capital R, then I understand that this E dot ds over this particular surface S, what it will yield me? It will yield me integration, like what was that? K Q, एक बार इसको ढंग से लिख लेते हैं, upon R square, 1 plus R upon lambda, and then I had, I think, e की power minus R upon lambda. This was my electric field, isn't it? And then I had शायद R cap, and then I will have some ds R cap, because on the surface, your differential element ds is in the direction of R cap. I mean, is that clear? And understand here R is equal to capital R. So I'll write R is equal to capital R, because on the surface your small r becomes capital. Is that clear? So what I would try to see, what I want to see is that what my E dot ds would come. What my E dot ds would come. So this is my first thing that I want to understand. What is my E dot ds? Okay, so E dot ds integration over the square would come out as E dot ds will be equal to what? It will be K Q upon capital R square, and then I have 1 plus R upon lambda. I have e की power minus R upon lambda, then I have R square, then I have sine theta, then I have d theta, then I have d phi, all those things. Okay, and if I want to integrate this entire thing up, what I'll get, I will simply get K Q upon R square, and I have 1 plus R upon lambda, e की power minus R upon lambda, and then I have this 4 pi coming out from here. R square would obviously get cancelled. So overall, I will get Q upon epsilon naught 1 plus R upon lambda, and then I have e की power minus R. Is that clear? I hope it is clear till now.
Yes, sir.
Okay. So यहाँ तक बात समझ में आ गई. अब देखो थोड़ा सोचते हैं इसके बारे में आगे. So Q upon epsilon 1 plus R upon lambda e की power minus R upon lambda. This is it. अब I know that my total flux, that is E dot ds, is dependent upon R. And if I want to slightly modify my this thing, and if I want that only my Q upon epsilon naught term should remain. What I want that only my Q upon epsilon naught term remains. I will have to do certain you can say manipulation or certain things that I'm going to write. What you do, एक काम करते हैं, instead of E dot ds, try to integrate something that I'm telling you. Let's say I have this spherical surface from which my flux was linked, and this spherical surface occupies a volume V. So instead, I'm just saying, just do another integral, that is V d tau. So what will you get? So if I want to integrate my V d tau, where V is the scalar potential, d tau is the volume enclosed within this spherical surface. So what I will get, I would simply get, I know my potential already. So my potential is kq upon kq e की power minus lambda r upon r. So instead of this, I will write kq upon r, and you have this e की power minus r upon lambda, and then instead of d tau, you can write r square sine theta, d theta, d phi, and dr. Now this is a volume integration of it. So I know you will be confused and you will be saying why I'm doing this. Just wait and watch what I'm doing. So for example, what will be the value of v d tau integral, this volume integral with respect to this, where integrand is your potential. So if I integrate it from 0 to capital R, what I will get? Let us see. Just let us see what I'll get. So I will get what? I will simply get this as, I think this would be like integrating k, q, and 4 pi would come out, forget about it. And overall, you will get integration r e की power minus r upon lambda dr from 0 to capital R. Is that clear? And if I integrate this stuff up, what I will get, like this is 4 pi, so this will be q upon epsilon naught, and then you try to integrate this thing. So if I want to integrate this, इसलिए मैं क्या कहता हूँ, देखो मेरी बात समझो, जो मैंने ऊपर किया था अभी पोटेंशियल निकालने के लिए, जनरली बच्चे ये सब चीजें आईलेट लेके चलते रहते हैं. आईलेट में दिक्कत कुछ नहीं है, बट आईलेट के हिसाब से तुम एक्सपोनेंशियल को इंटीग्रेबल टर्म लेके करोगे, बहुत दिक्कत में आ जाओगे. इसलिए बेटर ये है कि जस्ट रिस्ट्रिक्ट वन टर्म एंड ट्राई टू फाइंड कि कहीं ऐसा तो नहीं है कि इस पूरे इंटीग्रेशन में ये टर्म खुद रिपीट हो जाए. इस पूरे इंटीग्रेशन में ये टर्म पूरा रिपीट हो गया था नेगेटिव के साथ. सो यू विल फाइंड दैट दिस इज एन इजी इंटीग्रेशन. अदरवाइज you can do that also, but it will take a lot amount of time. Okay, so this is what I wanted to teach you from there. So this is like q upon epsilon naught, and if you want to integrate this stuff up, r e की power minus r upon lambda dr, what you will get? you can now use your Eilert formula, and now you can do your integration by parts only. Here you do not have to be at a problem. So what I'll do, I'll simply integrate this, place r here, minus integration, the derivative of r is 1. Integration of e to the power minus r upon lambda is this. And again you integrate it. I mean, this again you have to integrate it. You will get q upon epsilon naught, and you are getting minus lambda r e to the power minus r upon lambda from 0 to r. And instead now you write like this, from 0 to r की जगह 0. Is that clear? And then कहीं मिस्टेक नहीं होनी चाहिए, नहीं तो बहुत दिक्कत है. अगेन इंटीग्रेशन करोगे तो कितना आएगा, माइनस 1 अपॉन, सॉरी ऊपर आ जाएगा ना शायद, like this will be this will be minus r upon lambda from 0 to n. Is that clear? Now you find this particular value. So what I'm doing is I'm finding this particular volume integration, where your volume integration is done over this particular potential function, and you'll get q upon epsilon naught. I think this you'll get as 0. Forget about it. This you'll get minus. I think this will be lambda r e to the power minus r upon lambda. And is there a mistake somewhere? चेक करते रहना कहीं मिस्टेक नहीं हो जाएगा. पर इज देयर अ मिस्टेक, और देखते रहना ना कि गलती नहीं होनी चाहिए. ओके, देखते हैं जो भी. सो ओवरऑल दिस इज अ नेगेटिव टर्म, दिस विल बी पॉजिटिव टर्म. सॉरी, एक पॉजिटिव तो आएगा ही, तो पूरा नेगेटिव बाहर नहीं ले सकते. सो व्हाट आई विल डू, आई विल टेक दिस लैम्डा स्क्वायर आउटसाइड, सो आई विल गेट अ लैम्डा स्क्वायर आउटसाइड. q upon epsilon naught is also outside. These two terms are negative, so I'll write minus e to the power minus r upon lambda is common in that. Lambda square, if I take common, I'll get r upon lambda in the first term. The second term is 1 only. This is how it is. And this is, I think, plus 1. Is that clear? Is that clear to you? Like, all these things are clear? Okay. So now your potential, if I integrate in a volume which is enclosed by the spherical surface, and if I have found that what is the net flux enclosed, that is E dot ds, this surface integral comes out to be q upon epsilon naught 1 plus r upon lambda e to the power minus r upon lambda. So you understand, you can clearly see that this particular structure is quite similar. I'll write it all over again. So E dot ds क्या था, देखो ध्यान से देखो. E dot ds integration किसके बराबर था? Understand that E dot ds was, I think, q upon epsilon naught, and I think you had 1 plus r upon lambda and e to the power minus r. Is that clear? This is what you are getting, right? हाँ ना तो बोल दो कोई यार, क्या करो. So what you do, you simply divide this stuff. This is my equation number 2 and this is my equation number 1. So divide equation number 2 by lambda square. So if I divide my equation 2 by lambda square, what I'll get, E dot ds का integration over the surface plus integration v d tau upon r upon lambda square over the volume enclosed by this surface gives you what? It gives you q upon epsilon naught 1 plus r upon lambda e to the power minus r upon lambda. Then you have something minus lambda square will get, because you have divided it by lambda square, you will get minus q upon epsilon naught e to the power minus r upon lambda, and then you have this 1 plus r upon lambda, and then you have this extra term also, that is q upon epsilon. Is that clear or not? I mean, तुम ध्यान से देखो, अगर इस lambda square को divide कर दोगे ना, there will be some q. This term gets cancelled. Forget about it. So after all, this is your modified integral version, the modified integral version for your Gauss law. So now not only your electric flux could do, you will have to take this integration also, and only then it is equal to net charge enclosed divided by epsilon. Is that clear? Or it is not clear at all?
It's clear, sir.
है ना? I think this is clear. ठीक है, ये चीज समझने की कोशिश करो. हालांकि ये सबको एग्जाम में नहीं पूछेगा, but just to elaborate what I was idea that I was telling you. Idea याद रखना कि for other laws, like if you are not following inverse square law forces, then you will have certain modification to your original Gauss law. Only then you can write your net whatever integral on the left hand side as net charge enclosed divided by epsilon. So this particular extra modified term would be there. This is extra modified term. So this term would in any way be there. If you want to write this particular form in differential form, what I can do is, if I want to write this entire thing in differential form, so I know that if I can change this integration into volume integration by Gauss divergence theorem. So I'll write del dot E vector d tau integration over volume V, and this again integration over volume V 1 upon lambda square, and this is V d tau. This will be Q upon epsilon. Although I have taken here a specific case, it can be all the more made intricate by taking arbitrary surface and then taking a volume by solid angle also we can do. But I think this is quite sufficient for initial treatment that I have taken a spherical surface. If you don't want to take a spherical surface, you can derive the entire stuff up by doing this, but then you will have to take some solid angle into consideration. That would be a difficult approach to do. Rather, I have taken the simpler path. So overall, understand this would be my newer differential form of my Gauss law. Is that clear? Now, no longer your del dot D vector would be rho upon epsilon naught. Rather, you will have an addendum term that is V upon lambda square. Only then you can say that del dot E vector plus something, this additional term would give you rho upon epsilon. Is that clear? In examination, if it comes, you just at times see by the dimensional consistency of the four options, you will find that only one option would be correct. So like exam as I'm telling, अगर ऐसा कुछ modification आ जाता है, बस सिर्फ कुछ मत करना, देखना ये lambda की जगह कुछ और दे रखा होगा, पक्की बात है. Just dimensional consistency set कर लेना and then things are done. Don't worry about exam thing. समझ लो, एग्जाम में कुछ मत करना, बहुत परेशान हो जाओ ना कि यार ये कैसे होगा, इतना बड़ा प्रश्न नहीं होगा, तो ऑब्वियस सी बात है एग्जाम में कुछ मॉडिफिकेशन अलग तरीके से क्रिएट किए जाएंगे. तो यहाँ लैम्डा की पावर 4 होगा, लैम्डा क्यूब होगा. जस्ट फाइंड डायमेंशनल कंसिस्टेंसी. तो वन ऑफ द थिंग्स दैट कैन प्रॉब्ली रिजेक्ट टू और मोर देन टू ऑप्शंस would be to see the dimensional consistency, and then you just try to figure out कि इंटीग्रल की वैल्यू क्या है, and just add them up and find कि किससे क्यों कौन सा नोट आ रहा है. Don't try to go this way of approach. इस तरीके से मत करना. मान लेते हैं एग्जाम में if this question itself comes up, just try to play with the options. Like there are 4 options. Just try to reject and select a few by seeing the dimensional consistency. Like lambda के कुछ ना कुछ dimensions होंगे, because you see lambda is appearing on your e की power minus r upon lambda. So you know that r will have some dimensions of length. So overall, just play with a few options with your dimensional consistency, reject them up, and remaining you just try to find this integration, and then you just find to q upon epsilon naught r again. So this is what you can do in your examination. So this sums up our discussion on what can be a modified Gauss law. Like what can be a modified Gauss law had your Gauss law not had your Gauss law was not derived from a force which is an inverse square law force. Okay, so this is a kind of treatment that I have given to your newer treatment. Acha, ek kaam karu. Another case which we were take that case also, and let's see what can be the potential of it. What can be potential if not Gauss law and all those things? So if not Gauss law and all those things, what can be potential of this? So for example, now instead of inverse square law force, let us understand that if for simplicity, I'm just going to derive the potential part. Now, if the Coulomb's law take the form let's say k q1 q2 upon r की power 2 plus del, and I'm quite sure that this is not a inverse square law force. This is not an inverse square law force. So the first thing that I'm telling you, that all the other things except Gauss law would change. For example, for this particular expression, your energy would remain constant. So total energy remains constant, because you understand that this particular thing is a central force because it depends on R. So this is a conservative force. So total energy would remain constant. I'm just writing it in a loose sense. I mean, you can say what sort of energy you're talking about. Is it an isolated system or is it an interacting system? I'm just saying that total energy means the total potential energy and then kinetic energy of a system which is governed by such kind of Coulomb's law. The total energy would remain constant. Then what other thing you can see? It will admit a scalar potential. It will admit a scalar potential. Why it will admit a scalar potential? Because this particular force is a central force. And if it is a central force, then this is a conservative force. Also understand that this particular force will admit a scalar potential, means the force vector can be written as minus of grad of phi. And all those other things like work done along the closed path would be zero. Work done in moving a charged particle from point R1 to point A to point B would not depend upon the path taken from A to B. Rather, it would depend upon the initial and final points. All those things would remain the same. The only question that I'm asking is, do you think, what do you think would be the potential function? What do you think would be the potential function? Now you see, whenever like I will do all these things, difficult things also, like I will do, I will try to find the potential of a sphere using traditional approach and using the Gaussian approach. Now see, whenever you had this kind of thing in your school times, you know that अगर तुम्हें कोई conducting sphere देता था, if you had this conducting sphere which had charge q, and somebody asked you what is the electric field inside, you readily told that particular person कि नहीं electric field inside is zero. Why? Because if I make any Gaussian surface inside, my net charge enclosed is zero, so I'll write my electric field to be zero. If somebody would ask you what is the electric field outside this sphere, so you would readily say that this will be equals to nothing, this will be nothing, but it is equals to k cube upon r square. Is that clear? I mean, this is all these things are in your standard 12. So for example, if you had this distance r, you would readily say that my electric field would be this, and for all r less than r, you will say my electric field would be zero. And again, this is a conducting, I mean, I'm going to talk all these things in a little bit detail later on, but you can see that there's clearly a continuity in the electric field at the surface. So you will see that whenever you have a surface which contains charges, their electric field becomes discontinuous. The normal component of electric field is discontinuous. Here you can see this kind of observation being seen here. So all these things you study in your like MSc classes, the boundary conditions. But here you can see that on the surface, if you have some charge density, then the electric field becomes discontinuous at the surface. So overall, all these things become quite easy when you have this inverse squared law forces, because whenever you have inverse squared law forces, you can readily use this Gauss law, and you can find the electric field. And once you find electric field, you are in a position to find potential. But what about this particular problem? Again, the question that I want to ask, will Gauss law be still valid in the present form? So Gauss law will not be valid in the present form, means E dot ds would no longer give me q upon epsilon naught. Rather, there should be some addendum term. Only then I can find this. I can find this q upon epsilon. Like only if there is certain modification, only then it will allow me to write q upon epsilon. So obviously, I cannot use my Gauss law to derive my potential. So how to find potential for such a problem? Are you getting my point till now? I mean, जो मैं चीज समझा पा रहा हूँ, नहीं समझा पा रहा हूँ। कुछ समझ में आया, ऊपर से चला गया। भरत आया नहीं है? आ रहा है?
Yes, sir. Yes, sir.
एक काम करते हैं, let us take an easier case and then try to find the answer. So let us take an easier, because all these things are quite mathematically intricate. I just want to convey my idea. So let us take an easier example. Let's say, let us take a hollow spherical shell. Let us take a hollow spherical shell of radius capital R, and on which you have some uniformly distributed charge. Uniformly on which you have some distributed charge. Is that clear? We want to find potential as a function of R. Potential as a function of R at some distance R greater than R and R less than R. This is what we want to find. Is that clear? Now understand that this particular form of Coulomb's law will not allow me to use Gauss law in the present form that I used to do. Like again, I'm reiterating, if my law was an inverse square law force, then things were very easy. इनसाइड पता करना है, अंदर एक छोटा सा गॉसियन सरफेस बना है, यू से दैट नेट चार्ज इंक्लूसिव 0. आउटसाइड करना है, यू से दैट net charge inclusive q, then q upon 4 pi r square. All those things you've done in your standard 12, all these derivations we've done. Although I'll repeat it all over again, don't worry about it, but just for the sake, I'm just like writing it formula wise only. Is that clear? I mean, this is something that you know. I don't think this needs a explanation. Okay, but now here you see that this particular expression will not allow me to use this kind of Gauss law in this present form. So I'll either I have to modify my Gauss law, or I will have to do something else. Okay, or I will have to do something else. Is that clear? यहाँ तक समझ में आया? So what I would do, I would try to use integral method. I will try to use integral method. So इसलिए मैंने shell लिया जिससे कि थोड़ा life easy रह जाए. Because if I don't take shell, then I will have the charge density inside, and things will get all the more complicated. So what I'll do, I have simply taken a shell. For example, shape नहीं लेते हैं, use कर लेते हैं तो अपने पास. For example, this is my sphere. Okay, this is my sphere, and ठीक है, मान लेते हैं कि ये ऐसा कुछ करते हैं. If I want to cover shell, what I will do, I will take small, you can say rings. So I'll take small rings. On these rings, there will be some charge present on the, because there is a charge present on the surface, so there will be charge present on these uh, thickness, like on the thickness of these rings, there will be some charge. Is that clear? ये चीज समझ में आ रही है? So what I will do, I will divide my shell into small rings. Is that clear? And let us say कि ये जो अपनी origin से it is at a distance, let's say capital. This will be at a distance capital R. That is, I don't think there is an issue for this. And let's say I want to find my potential at point P, which is at a distance small r. This distance, what should I write? Let's say this is my theta. It is my theta. Then if you remember, if this is a triangle, this is your theta, and I want to find this side, and given these sides are a plus b, then you know that a square plus b square minus 2ab cos theta is equal to, I think, c square. Is that clear? ये याद है formula? Like this is something that you know from your law of cosines. Is that clear? Like a side c होती है ना, so your c square is given by a square plus b square minus 2ab cos. Is that clear? So I will
Yes,
write
sir.
this, ये वाली side I'll write as over sorry, this will be root over r square per small r square minus 2 capital R small r cosine theta. This is from law of cosines. Okay, this is from law of cosines. Is that clear? ये चीज समझ में आ रही है ना? ये कैपिटल आर है, स्मॉल आर है. Don't worry about it. What will be the area of this particular ring? So area of this ring would want me to write two length expression. The one length expression would be the length of the circumference. Another would be this like small thickness. So area element, you can say that differential area element of the ring. Differential area element, like differential area of the link. This ring will be 2 pi. I can write capital R. This, if this is R, this will be what? This will be, I think, R cos theta, and this will be R sin theta. So 2 pi R sin theta would be this circumference. And then if this is theta and a small differential, if I take this is R, this is theta, this will be some d theta. So this particular thing would cover up your this thickness. So this will be like R d theta. So this is the area, like small differential area of this ring. Are you getting my point? So, and this, in this particular area itself, your charge is distributed. So what will be charge distribution? So my total charge was distributed initially on the surface of the sphere. So total charge divided by 4 pi r square. If I have not written capital Q, kindly write that capital Q of with uniformly distributed charge, capital Q. Okay. So sigma is given by q upon 4 pi r square. So entire charge was distributed uniformly on the square. So sigma is given by q upon capital 4 pi, sorry, q upon 4 pi capital R square. What will be the charge distributed over this ring? So charge distributed over this ring would be sigma into ds. Okay. So charge distributed, I'll write here again. Charge distributed over the ring would be sigma into ds. And ds I know is this. Is that clear? So that will be equal to, I think, that will be equals to sigma. देखो यहाँ पे क्या था? Sigma था q upon 4 pi r square, and then you have this 2 pi r square, and you have this sine theta, and then you have d theta. So all these things gets cancelled. So you have only uh, q upon 2 मैं ऐसे लिखूंगा ना मैं इसको, ये हो जाएगा q upon 2 sin theta. Is that clear? यहाँ तक कुछ गलती तो नहीं कर रहे हैं? कुछ भी गलती हुई then things will be difficult for us. Now we have to see the potential at point P. We have to see the potential at point P. So this is the ring. I mean, this is the ring. I want to find what is the potential due to this particular ring at particular point P. So if you remember the formula for electric field due to ring, वो कितना होता है याद करो. I think जितना मुझे याद है it is, पता कर ही लेते हैं. इलेक्ट्रिक फील्ड के कारण हमने डिराइव किया उसको फर्स्ट क्लास में, इफ यू रिमेंबर. इसका एक्सप्रेशन बताओ फटाफट से. इलेक्ट्रिक फील्ड कितना होता है? आई थिंक के क्यू अपॉन रूट ओवर एक्स स्क्वायर प्लस आर स्क्वायर, ऐसे कुछ. ओके, 3/2 तक चेक एक बार चेक करो प्लीज. इसका 3/2 तक जस्ट चेक इट वंस. एक बार इसको चेक करो. के क्यू एक्स,
यस सर 3/2 तो होता
है ना? ऐसे कुछ होता है ना. इज दैट क्लियर? ये होता है ना के क्यू एक्स अपॉन एक्स स्क्वायर प्लस आर स्क्वायर की पावर 3/2.
यस सर.
एक बार इसको चेक कर लो, अदरवाइज थिंग्स विल बी डिफिकल्ट. फिर वहीं अपने दिक्कत आना चालू हो जाएगी. ओके,
यस सर सही है सर, चेक कर ली.
ठीक है. एक काम करो, इसके कारण अब यही चीज आप लिखो माइनस डीवी अपॉन डीएक्स इज इक्वल टू ई, एंड जस्ट फाइंड मी दिस potential as a function of x, so that I can use this formula readily here. Because potential due to this ring will be known, then I will integrate this stuff up, and then I will find the total potential due to the entire sphere. Idea clear है ना? मैं क्यों नहीं यूज कर पा रहा हूँ गॉस लॉ? वो समझ में आ रहा है. देखो गॉस लॉ मैं इसलिए यूज नहीं कर पा रहा हूँ because now there is no longer my inverse square law dependence. I will have to go with this crude approach. मेरे पास कोई दूसरा रास्ता नहीं. So what I have taken this ring. I have distributed this entire sphere into these small rings. I will try to find the potential due to these small rings at point P. I will integrate all those contributions, and eventually I will find the potential due to the entire sphere. Is that clear? At point P. Just find me this expression to V. 2 मिनट लगेंगे इसको इंटीग्रेट करो फटाफट से, तो हमें एक आइडिया लग जाएगा कि हमें यहाँ पे क्या यूज करना है. So I'll write phi. This is potential due to this differential ring. What should I write? Small ring. जल्दी 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 पता करो फटाफट से. आपके पास कम है भी कम है. Otherwise I will have to take tomorrow class. इसलिए जल्दी पता करो. I think this will be, करो इसको integrate करेंगे तो I think this will come out as, I think k q upon root over r square plus x square. एक बार चेक करो इसको. ये
हाँ सर यही आएगा.
ये ठीक है. सो अब इस रिंग का अपन पता करने की कोशिश करो. व्हाट विल बी द पोटेंशियल ड्यू टू दिस रिंग? what will be the potential due to this ring? Is that clear? इसको अपन कुछ लिख लेते थे बड़े एक्सप्रेशन को, लेट्स से इसको लिख लिया अपन ने L, इसको अपन ने लिख लिया अपन ने L. कहाँ गया यार, एक एक्सप्रेशन. Potential due to this ring will be K dq upon root over r square plus x square. क्या होगा? I think root over r square plus x square would be equivalent to writing this. I think like r square plus x square क्या है? यही तो होता है. This is root over r square plus x square, isn't it? In our terminology, we have written as this as L only. So we'll simply write it as, let's just integrate कर देते हैं सच हट. चलो ठीक है. This will be. Is that clear? कुछ गलती कर रहे हैं, चेक को कुछ तो इशू हो रहा है. ये dq पर L ही हो जाएगा क्या? तो ये तो बिल्कुल पॉइंट चार्ज वाली बात होगी. इससे तो फिर डिराइव करने वाली बात हो गई वापस से. चलो डिराइव ही कर लेते हैं. दिस इज योर d5. सोचो अगर इसके ऊपर चार्ज dq लिमिटेड है, इसके ऊपर चार्ज dq लिमिटेड है, तो इफ आई वांट टू, पर अगेन वही रिंग का कंट्रीब्यूशन अपन रिंग पे निकाल लेते हैं ना. व्हाट विल बी द क्या कह सकते हैं, पोटेंशियल ड्यू टू रिंग एट दिस पर्टिकुलर पॉइंट p. व्हाट विल बी द पोटेंशियल ड्यू टू रिंग एट दिस पर्टिकुलर पॉइंट p? वही पता कर लेते, बेटर रहेगा. आपको टाइम वेस्ट रहेगा. मुझे सिखाना था ये. देखो दिमाग खर्च करना ही पड़ेगा मुझे. इससे बजाय अपने काम करते हैं तो इससे अच्छा इंटीग्रेट ही कर लो. इससे अच्छा इंटीग्रेट ही कर लो. इससे अच्छा इंटीग्रेट ही कर लो, ज्यादा आसान हो जाएगा. ठीक है. सो फॉर एग्जाम्पल इसको छोड़ो, बिकॉज ऑल दीज एक्सप्रेशंस, अपना दिमाग काम नहीं कर रहा है. ऑल दीज एक्सप्रेशंस वर वैलिड only for inverse square law forces, right? So if you had this inverse square law force, only then this was valid. अभी तो हमारा फोर्स का एक्सप्रेशन ही चेंज हो गया ना. कैसे काम चलेगा? बिकॉज इफ आई राइट दिस रूट ओवर आर स्क्वायर प्लस एक्स स्क्वायर, दिस विल बी लाइक रूट ओवर आर स्क्वायर प्लस एक्स स्क्वायर. तो यही हो गया. तो ये तो सिंपली एल ही आ गया यहाँ पे. तो ये तो वैसा हो गया जैसे कि नॉट रिंग नहीं ले रहे, पॉइंट चार्ज ही ले. तो जब अपन से कुछ गलती हो रही है, काम करते हैं. लेट अस गो बैक एंड अंडरस्टैंड कि हमारा कूलम्स लॉ क्या था. तो कूलम्स लॉ, फोर्स इज गिवन बाय k q1 q2 अपॉन, आई थिंक क्या था, आर की पावर 2 प्लस डेल था हम लोगों ने जो लिया है. इसके कोरस्पॉन्डिंगली अगर मैं पोटेंशियल फंक्शन लिखूंगा तो कैसा आएगा? माइनस dv अपॉन dr शुड बी इक्वल्स टू एफ आर. और अगर मैं इसको इंटीग्रेट करूं v एज अ फंक्शन ऑफ r, दिस विल बी लाइक एफ आर dr इंटीग्रेशन फ्रॉम इंफिनिटी टू r. इज दैट क्लियर? और फील्ड की जगह फोर्स की जगह फील्ड अगर ले लूं तो कितना आएगा? माइनस ऑफ k q, आई थिंक दिस इज r की पावर 2 plus del and then this is dr integration from infinity to r. ऐसा कुछ. Is that clear? कुछ गलत तो नहीं करो, प्लीज चेक करते जाओ, नहीं तो गलती हो जाएगी फिर आपको पता नहीं चलेगा. Is that clear? So what would be potential? Potential would be minus k q, ये कितना हो जाएगा? r की पावर -2 माइनस डेल प्लस 1 अपॉन -2. क्या गलती होगी? r की पावर, दिस इज r की पावर 2 प्लस डेल ना, राइट? अगर मैं इंटीग्रेट करूंगा तो ये तो आएगा, आई थिंक 1, यही तो आना चाहिए. प्लस. इज दैट क्लियर? हाँ ना तो बोलो महाराजा. आर से इंफिनिटी. ठीक है. सो पोटेंशियल एज अ फंक्शन ऑफ आर कितना होगा? फटाफट से बताओ. पोटेंशियल एज अ फंक्शन ऑफ आर व्हिच आई कैन डिराइव फ्रॉम दिस इलेक्ट्रिक फील्ड एक्सप्रेशन, जल्दी से. दिस विल बी, आई थिंक, इफ यू प्लेस इंफिनिटी अप पर नीचे आर रखेंगे तो k dq upon r की पावर 2 plus. Just give me a minute. We'll take a lecture again. I think this is short time is left. Just give me 15 minutes more ना. एक मैं और लिंक शेयर कर रहा हूँ. 15 minutes में we'll finish this one.